Okay, press pause before working on the examples that I present here, so that you can try them on your own before looking at how I solve them. Okay, here we have 2 points in the XYZ coordinate system. We have an X, a Y, and a Z there, and I'll call this X2, Y2, Z2. Actually, let me call the first one X1, Y1, Z1. So I want to find the distance between these 2 points. Well, the distance formula says, to get that, I take the square root of x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. So for this particular example, underneath the radical I have 1 minus negative 4 squared plus 3 minus 1 squared plus 6 minus negative 2. And I have the square root of all that. So 1 minus negative 4 is 1 plus 4. So I get 5 for that. So 5 squared. 3 minus 1 is 2. So I have 2 squared for that. 6 minus negative 2 is 6 plus 2, which is 8. So I have plus 8 squared for that one. And I take the square root of it. So now we're just going to plug this into our calculator. So we get the square root of 25 plus 4 plus 64. And just type that into our calculator. And we get around 9.64. Okay, so here I have a rational function, f of x equals negative 3x plus 5 divided by 4x minus 2. And I want to find out what value this function approaches as x gets infinitely larger. Okay, so what the problem is really asking you is, what are the horizontal asymptotes? Or what is the horizontal asymptote of negative 3x of y equals negative 3x plus 5 over 4x minus 2. So to figure that out, we're going to look at the degree of the top. The degree of the top is 1, because the highest power of x that appears there is 1. And we're going to look at the degree of the bottom. The highest power of x there is 1 as well. Whenever the degree of the top is equal to the degree of the denominator, so whenever the degree of the numerator is equal to the degree of the denominator, the value that the function approaches as x gets infinitely larger is the ratio of the leading coefficients. Okay, so the ratio of the leading coefficients, the leading coefficient of the numerator is negative 3, the leading coefficient of the denominator is 4, so the function approaches the value negative 3/4 as x gets infinitely larger. Okay, here suppose we know that x minus 3 is a factor of f of x equals x cubed plus some number t times x squared minus 17x plus 60. We want to find the value of t. Well, I know from a theorem that x minus k is a factor of f of x if and only if f of k equals 0. So that means that since x minus 3 is a factor of this, if I plug 3 in for f, I get 0. Well, let's see what I get when I plug 3 in for f, symbolically. I have 3 cubed plus t times 3 squared minus 17 times 3 plus 60. All right, let's clean this up a little bit by multiplying 17 by 3, doing 3 cubed, and combining these 3 terms here. So if we do 3 cubed minus 17 times 3 plus 60, is equal to 36. So we have 36 plus t times 3 squared is 0. 3 squared is 9. So we have 36 plus 9t is 0. We'll subtract 36 from both sides. So we get 9t is equal to 36. Divide both sides by 9 to find the answer. And we find that the value of t is negative 4. Okay, here we have a right circular cylinder. It has a radius of 4 and a height of 7. So base radius of 4 and height of 7. So here's our cylinder. So the base radius here is going to be 4, the height 7. So now, P and Q are 2 points on the surface. We want to know the maximum possible distance between P and Q. Well, if this is P and this is Q, then the distance between them is just the radius of it. Okay, so that would be 8. If Q were instead right here, so to get the distance, we're measuring just the length of the line segment that joins them. Okay, so in fact, the way that we're going to get the biggest possible distance between P and Q is if one of them is here and one of them is here. Okay, so it's along this kind of diagonal of the cylinder, we're going to get the maximum distance between the points. So if we form this triangle, the length of the hypotenuse of that right triangle, that's going to be the maximum distance between P and Q. Well, the triangle goes along the base of the cylinder. So since the radius of the cylinder is 4, the length of this triangle is going to be the length of the diameter, and that's going to be equal to 8. The height of the triangle is just the height of the cylinder, so that's 7. So now we can use, since we have a right triangle here, we can use the Pythagorean theorem to find the length of that diagonal. So it's going to be the square root of 7 squared plus 8 squared, and that's the square root of 113. Okay, so the maximum distance, the maximum possible distance between P and Q is the square root of 113.